First, I'd like to thank the Prefect team for inviting me out to this. I'd also like to thank the Clay team for hosting us at their space. It's a very sick space and a very cool disco ball. Awesome. So yeah, I'm Cesar Duran. I'm a senior software engineer at RAMP, and I'm specifically on the ML platform team. And I am the tech lead for RAMP Research, which is our AI data analyst agent that we use internally. And today I'm going to talk to you about how to build an AI data analyst. But first, we're going to start with talking about why we want to build an AI data analyst. So it fundamentally boils down to a data service bottleneck. We have James on our data team, who is a wizard of knowledge on RAMP data. Because of his expertise, he ends up getting a lot of data questions from multiple folks, including Jeff, our chief product officer. And it's because James is human, many of these questions go unanswered and sometimes even unasked. And so it's crucial that we lessen the load on James so that he can get back to working on the actual interesting data problems that we have going on at RAMP. So, for example, this is a little sneak peek at what RAMP Research can do. Here I have Noel, who's basically asking about ways in which we can correlate our contribution profit based off of how achieving 100% share of market goes. And as you can see, RAMP Research essentially returned the response in about 4 minutes. I think James would struggle to, as much of a wizard as he is, he would struggle to hit that same time period. So yeah, so hopefully this gives a little insight as to what the power of RAMP Research can serve. And now we can talk about how to build it. So first, let's start with grounding ourselves. In an ideal world, our tables are easily defined with easily knowable table names. We got users, cards, purchases. And we may even have descriptions for those tables and columns as well. But as we all know, the ideal world is nothing like that. This is actually a representation of all of the tables that we have at RAMP. And if you look in the bottom left corner, this is only a subset of the grander picture in which we have all of these tables that spread across the entire table catalog. It's difficult to build a solution that can handle any set of table catalog. And so today I'm actually going to talk about how we built the AI data analyst. Taking a time travel step back, when we go back to early March, we can remember that Claude 3.7 came out. Claude Code was also announced. MCPs were starting to hit their stride, and Claude Code was really showing what you can do with MCPs. RAMP also announced a new funding. So as all funding announcements do, it led to new customers, new data questions. So then I took a crack at our first iteration, where we basically set up Claude Code with a Snowflake MCP, essentially just wrapped around query calls to Snowflake. So now we can already see the foundations of an LLM agent that can interact with our Snowflake warehouse in a loop using a bunch of tools. Of course, just being able to execute queries is not going to be enough. You're going to face a lot of exceptions, a lot of issues. It's really difficult without proper prompting to get good SQL queries. You can actually see on the left image, we have a representation of our semantic similarity distribution of our table descriptions. And so as you can see, we needed a way to feed that table information back to the LLM before it was making those SQL queries. This led to the introduction of the next tool, the ability to search through your tables. So Claude would then be able to take keywords that it thinks are necessary in answering the question, send it to the search table tool, which will semantic search against our table descriptions and return lists of the most similar tables, so that way it can reliably execute those queries. So now we have the foundation of what I think really works here. We have the discovery phase, which is where we're actually figuring out what is our landscape, and our execution phase, where we know our landscape and we want to begin executing queries onto it to get a full picture. Now we go into the next problem, which is a giant input prompt. So everybody knows your initial prompt does matter a lot. And so we put a bunch of information in our initial prompts. It had everything you ever needed to know about RAMP, including everything you needed to know about RAMP's tables. So here I have a little little snippet of it, but to the right, you can actually see the full length of that initial prompt. And that is what we have currently in production. So we have this giant input prompt, and we can't really scale this very well because we're still going to keep growing. So what can we do? With that, I introduce what we call the context layer. And I'm going to dive straight into what our production representation looks like. So the context layer essentially enables the quality in the discovery phase. So with these new concepts that we outline, these are essentially documents that contain all of the understanding you need to know about RAMP's tables, RAMP's business, RAMP's jargon, everything you need to know. And so on the right, I actually highlight what our general workflow looks like, where you could think of it as we're also trying to look at this from the stage of how would a data analyst handle this problem? Well, first, they're going to start off, clarify some jargon. Let me read up on the domain that they want to know about. Let me find the tables that are related to that domain. Let me understand what the documentation around those tables looks like, and let me start inspecting those tables using SQL queries and establishing distinct values from each of the columns and stuff like that. And so now with this, we essentially circumvent this whole bottleneck that we have, where now all of the rest of the RAMP team can just make requests to RAMP research, and James is now freely able to answer Jeff's questions. And in fact, I did not leave it on here, but RAMP research does around 1,000 questions a week, so those would be 1,000 questions that would be left unanswered. So now we get into the painful part, which is the slow burn, which is the fact that our context layer cannot be built in a day. There's a lot of difficulty with writing a context layer, especially in a technical context, because as I show here, that description of remote bills is going to get me nowhere if I actually want to answer the question about remote bills. And so that means we need to go into each of these docs, understand how it is actually represented in the data, and label that so that RAMP research can actually effectively execute. I like to make a comparison to Civ 6. If anybody's played Civ 6, you start out slow, you start out with very little ground, but as it grows, as you develop, you discover new areas, you explore what is known, you establish grounds, and you are able to confidently answer the questions in the smaller sphere, and then explore in expanding your sphere. And so now I will get into some future theory on how we plan on improving even this context layer. So that context layer does make sense, and it will work for a while, but we are going to run into the same issue where now each of those domain documents are going to also be large in size. And so we need to figure out a way in which we can break that out and be able to only feed the information or the context that RAMP research needs when it's answering a question specific to that context. And so this is all theory, but I think that the way in which you approach this is similar to the way in which a college student approaches learning. You start off with Bill Pay 101, and then once you've learned about Bill Pay 101, you might need to know about payments, you might need to know about accounting, you might need to know about batching, and you might take those classes so that you can get that information. And then once you're able to collect your information with this knowledge tag, you're able to then go and answer the question with as little amount of context as possible, but still enough. And then the other idea is for using Claude Skills. So Claude Skills are a relatively new concept, which is it's essentially a way in which we can define a repeatable workflow with pulling data for people across the org. So people tend to have a specific pattern in which they want to retrieve data. So for example, if they're looking for customer references to a prospect that they have, there's a typical workflow in which a regular data analyst will follow, and it is suggested that the AI data analyst follow that same workflow. And so if you establish Claude Skills as a way in which you can define those workflows, then you would get a lot more reliable output and a lot more deterministic output. And lastly, I'll leave us off with one other request that I made to Ramp Research, which is, what should we do after PyAI? And so I asked it based off of the transactions that we have in Ramp's data. And the top answers are MTA and cursor. So that means we're taking the train back to work.